Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Greetings, all you vintage audio hound dogs and Sansui samurais. This is Retro Ernest of Retro Electro Tech. And on the bench here we have twins. We have two Sansui 881s. So these are from two different customers, just, they happen to be in the shop at the same time, coincidentally. So, what are we going to do? Well, for starters, I'm going to try to get through this as fast as I can, these two preliminary evaluations. I figure, hey, since they're both 881s, I might as well just evaluate them at the same time. So before I get into the usual stuff, safe power up, going through all of the functions so as to see what is going on, I'm going to start by, of course, popping the hoods on both of these and, kind of doing a once over, make sure there isn't some serious red flag indicators that are just begging me not to power them up. And we'll, check the fuses, stuff like that, okay? On one of the units, the tag indicates, because I can't remember off the top of my head, but one tag indicates no audio. I believe this unit here, and this one, the problem was described as a channel issue, so an intermittent channel. Anyways, like I said, we'll go ahead and get into popping the hood or hoods, plural, and see what there is to see. And I almost forgot, for those of you not familiar with these fine receivers here, the Sansui 881s, these were produced in, I believe, 74 through 76, somewhere in there. And these psycho samurais come stepping into the ring swinging their swords at 60 watts per channel into 8 ohms to rattle your bones. Frequency response of 10 hertz to 30 kilohertz. And a THD of 0.3%. So let's go ahead and get into the evaluation. Okay, so starting with the unit on the right of the bench, because it's on the Lazy Susan. I got the hood popped, as you can see, of course, and I'll kind of give her a little bit of a spin here, and we'll just kind of zoom on in and take a look, and probably won't be able to see too much detail, or maybe you will, I don't know. But it's pretty dirty, the usual crusticles that inhabit these old units. Okay, but from what I can see thus far, and let me continue to spin it around here. Yeah. Okay. From what I can see, everything looks like it's intact. I don't see anything too scary. I mean, no charcoal briquettes or anything, so that's good. Yeah, nothing jumped out at me like a rodent or an angry insect or anything. So yeah, pretty good. So I'll go ahead and reposition the camera and take a look at the back side, the fuses, or just lower the camera and all that, so I'll be right back. Okay, and here's the back side, obviously. And you can see if I zoom in, we have a lot of webs and that sort of thing. So there might be spiders lurking about. Alright, so anyways, let's check the fuse, make sure it's the right size fuse and all that jazz. We should have a 5 amp fuse in here. So oops, the probes of my tester were touching together. So, real quick, I'm just looking at the fuse through my little magnifier here because I don't have the greatest eyes on planet Earth. Yep, 5 amp fuse, and it looks like it's intact all the way through, but just for the sake of being thorough, let's go ahead and just check her out. I'm sure it's fine. Yep, okay. So I got the fuse back in, and I'm gonna do a once over one more time, just on the inside. I'm gonna just do that off camera, just get my get my light into the equation, my magnified light there, and just kind of look around, make sure I'm not overlooking anything, and then go into a safe power up on it, get a signal piped in, and get it hooked up to the scope, dummy load, the usual stuff, and just start kind of checking things out and go from there. And of course I'll check, for offset and all that stuff. But anyways, let me go ahead and get to that. Okay, and we're looking at the backside and top area of the second unit on the left side of the bench. Okay, this is the one we were looking at just a moment ago. And I already checked the fuse off camera because I don't want to do identical, or repeat identical processes back and forth and all that and eat up more time, so forth and so on. So anyways, the fuse is looking good. The only thing is that there was a 3 amp instead of 5 amp. A 3 amp fuse is the one you would use if you were using it with 240 volts. Okay, so I took the voltage selector cover off here and made sure that the voltage selector was appropriately set to, in this case, 117 volts, 120 volts, whatever, tomato, doesn't matter. So anyways, and it was, I just wanted to be sure that, it wasn't still configured to 240 volts, which I didn't think it was because I know the customer was using it here in the US. So anyways, everything's okay there. Eventually I'll put a 5 amp fuse in there. The fact that it's an underrated fuse, I'm not worried about it. Underrated for 120 volt operation, but as long as somebody didn't stick a bigger fuse in there. And as far as the inside here, I'm not going to really hover over the top. I'll zoom in just a little bit here and kind of pan around, but everything looks pretty much the same as far as the crustiness, the dirt and debris accumulation. Nothing out of the ordinary, nothing really bad. As usual, I went in there with the light, the magnifier, and checked things out just real quick, just a cursory, preliminary look at things, and everything's okay. Nothing looks stressed out, burned, crispy. No bulging electrolytics, at least that I could see. Nothing leaking on the boards. No funky looking wiring. The obvious stuff, in other words. The only thing I did find, and by the way, I forgot to mention, on both units, let me remove something that's in the way. On both units, I went inside and checked the internal fuses, and on this one here, there was a problem. I did find a open fuse, so I'm going to reposition the receiver here and talk about that a little bit. Okay, so this is a fuse F3 that's kaput, and that's in line with one of the 31 volt windings, which in turn is in line with a shorted diode here, back behind here. And there may also be a problem with this pass transistor, also part of that circuit, but I'm having a hard time getting my leads down there. And the heatsink for this transistor is secured to the board, so I can't bend this transistor over to kind of position my leads or my probes on the leads. So anyways, the readings I was getting were inconsistent is what I'm trying to say. So I'm going to end up just pulling it from circuit, testing it, and making sure this pass transistor is okay or not. But otherwise, the fuse I pointed out was the only one that was bad between the two units. So if I'm not mistaken, I believe that that circuit there feeds the tuner board. I'd have to look at the schematic again, but I believe it does. It feeds some circuitry on that tuner board. So what I'm going to do now, just real quick, before I start the safe power up and get a little bit more into diagnostics on this unit here and function testing on the other one and just function testing on both of them, is I'm just going to pull the bottom covers off, just do a quick visual underneath and make sure everything looks okay, that nothing looks scary, and then I'll go ahead and start the safe power up and function testing and some more diagnostics as needed. But the one thing I'm not going to do, I'm not going to repeat every process between both receivers, because that would take forever. But what I am going to capture on camera is the general function testing between both units and anything that I find that's worth noting. And when I get the signals piped in and I'm going through and again function testing everything, looking at the waveforms, the waveform characteristics and all that, and whatever, again, what's noteworthy, but little odds and ends here and there. I'm not going to repeat the process between both units, not on camera. So let me go ahead and get to that. Okay, so I'm going to begin the power up, safe power up, starting with this receiver here on the right side of the bench. By the way, I took both bottom covers off of both receivers, took a quick look inside. Everything looked okay, nothing out of the ordinary. I slapped the covers back on for now, even though I'm going to be getting in there later because I don't want loose covers all over the shop. So anyways, what I'm going to do is just briefly touch on the current limiter, the device I use to perform a safe power up. And I've done that before. I've explained in more depth in other videos what that's all about. So in this video, I'm not going to do that. I'm only going to touch on it because for those that are not familiar with what a current limiter is and how a safe power up is performed, for the most part, that's what I'm going to get into. Especially for the customers of these receivers, when I send the video links, if they decide they want to watch this stuff, they'll kind of get an idea of what's going on and how powering up these receivers is handled safely. So let's go ahead and I'm going to change the camera view and focus in on the current limiter and touch on it briefly. Okay, so that's our current limiter there in the white box with the 3 bulbs and the 3 little switches on the side there. And just as the name implies, it limits current to the device under test, our receiver there. Okay, so, and the way it limits current is resistance. The filament resistance of the bulbs that we choose is what limits our current to varying degrees. So the filaments are resistive elements, and think of resistance as just that, resistance to the flow of current. So it's resisting current and limiting the current to the device under test there. So why do we want to do that? During a safe power up, we want to limit current because we don't know exactly what's going to happen with this device under test. And typically we want to start out with more current limiting as opposed to less current limiting. So we're going to choose the size bulb based on how much current we want to limit. Our smaller wattage bulbs will give us more resistance, hence more current limiting, as opposed to our larger wattage bulbs. But we use them in combination. That's why I have 3 bulbs there. So the switches on the side there just allow me to choose one bulb, any choice of the 3 bulbs, or I could choose a combination based on, again, how much current limiting I want. And what we're doing is we're starving the device of current, because when a device does decide to poop the bed, fail, go into meltdown mode, short out, or whatever, it needs fuel to do that. It needs current to do that. Okay? Think of a small fire. If you want to keep that small fire small, you limit the amount of fuel you're feeding it. And if all of a sudden you were just to throw the right type of fuel, the fuel that it wants to really burn, so that it can go out of control. If that little fire wants to go out of control and you give it the nice dry fuel or fuel soaked in flammable liquid, gasoline or whatever, along with wind, well, it's going to combust, it's going to burn out of control, the wind's going to spread it all over the place. What starts out as a little tiny fire ends up burning down an entire forest or an entire neighborhood, whatever the case. So by limiting the consumption of fuel, even with this device under test, limiting the consumption of current, we're not allowing it to have that fuel that it needs to run away, okay? So that's why we're powering it up safely with a limited amount of current that's dictated by the resistance of those bulbs that the bulbs provide based on, the size of the bulb, meaning wattage. So that's what we're ultimately doing here. And so I'm not going to go into a lot of detail otherwise, but with bulbs as our resistive element, we also have the benefit, of course, of watching the luminescence of the bulb, the brightness of the bulb. So that's important because that's what we're monitoring. When I power this up right now, I'm going to start out with the 40 watt bulb because I want more current limiting, and you're going to see it initially when I hit the power button. You're going to see it come up bright, and then it's going to dim back down. It's going to come up bright as the larger caps there, those two large round cans, when those power capacitors come up to charge, when they're coming up to charge, it's going to draw current and make that bulb glow bright initially, and when it comes up to charge, those caps come up to charge, it's going to dim back down, and there you go. And the filament is going to sustain at a low luminescence level, or it's going to, in other words, glow dimly. That's another name for these current limiters too. It's called a dim bulb tester. So it's going to glow bright initially, come back down, and it should sustain at that low level of brightness. And that's what I kind of want to see there. I want to watch that over time, and I don't want to see that deviate. If this thing is going to fail, again, remember, it wants more fuel to do that. So if it was going to start to fail, you might see that bulb start to kind of flicker and brighten up, maybe fluctuate, or it's going to all of a sudden just go bright again, or maybe upon power up it's going to go bright and it's not going to go back down. It's just going to hold there because something's trying to draw heavy current and run away. So by monitoring the bulb, if it stays dim like that for several minutes or however long, then typically that's a good sign, and you might give it a little bit more current. And if it behaves itself, you'll give it a little bit more current still. And if you feel safe enough, then eventually you can let it off of the current limiter and move on with testing and doing what you got to do, while the device is powered up. So that's what I'm going to do here. I'm going to go ahead and power it up right now and watch that little bulb there. Okay, see it come up bright initially and it dimmed back down right away. And then you heard that click too. Sometimes depending on the size of the device under test, because you size your bulbs and how much current you're going to initially give a piece of equipment a lot of times based on the size of the unit. So if it's a big old bruiser of an amp that consumes a lot of current during its normal operation, well, you size your bulb accordingly, and then you decide from there how much current you're going to starve it of based on the wattage of the bulb and so forth. But sometimes when it's heavily current limited, depending on the size of the device, like a receiver or an amp that has a protection relay like that, sometimes it's starved of current so badly that when you power it up, you'll see the bulb glow bright, come back down a bit, and you're not going to hear the protection relay kick in because it's too current limited. It's too heavily current limited. And sometimes if it's a big old bruiser of a piece of equipment and you have a really small bulb initially current limiting it, that bulb will glow bright and it'll only go down a little bit. It's going to stay pretty bright, and that's normal because of the amount of normal current draw that device under test is trying to pull, because it's a bigger piece of equipment with more of a demand. So, you know, you kind of get my point there. This is a smaller receiver overall, doesn't draw, a heavy amount of current. So that's why that little 40 watt, it glowed bright initially and came back down, and it's sustaining nice and dim right now. And that's about it. So that's something worth noting as well. So we heard the protection relay kick in though. That's kind of where I'm going with this. So it went bright, dimmed down, and then you heard a click. So it had enough current to activate that protection relay. So there you go. I think this explanation was long enough. And that's usually the way it happens. So I'm going to go ahead and monitor things for a while, and if everything's behaving itself, I'm going to incrementally increase the current until I'm satisfied that everything's okay, and then I will be back and we'll get into some function testing. Okay, so I've been monitoring the device under test for quite some time, maybe about a half hour or so. Not a single hiccup. So I'm going to go ahead and check the DC offset before I get a signal piped into it and get it hooked up to the scope and so forth, and start seeing what's going on both channels. Again, on the tag I have it written down that there's a channel issue. So that's what I was told by the customer sometime back. So I'm going to see if that's the case, or if we're dealing with really intermittent controls, or badly intermittent controls causing some issue on one of the channels, or whatever the case, or if there is in fact something going on any one of the channels. I don't really know yet what's going on. That's really all I know. And let me go ahead and check the DC offset here. Okay, our right channel, 9, well, it's dancing around a little bit, but it's in the low millivolts, as you can see there. Okay. Now let's go over here to the left channel. Low millivolts, it's kind of bouncing around. So that's good anyways. Nothing startling there. And I'll mess around with that a little bit more, once I get into things a little bit more, and then I'll of course check the bias and all that stuff as I get into things a little deeper. But for now, I'm going to go ahead and get a signal in it, get it on the scope, and start manipulating the controls, going through those and seeing what there is to see. Okay, so let's go ahead and get to that. Okay, and here we are, all of you fine human beings. I'm still letting this thing, simmer here and just kind of chill out. And so far so good. It's been stable throughout that whole time period that I've been running it. I have a 1 kilohertz tone piped into auxiliary 1. It's hooked up to the scope, and I do have both channels as of right now, but I haven't touched any of the controls yet. I haven't, other than the volume, just to bring up the waveforms just a little bit. So this is just the usual down and dirty test to confirm that yes, it's outputting on both channels. I have my signal in it, I'm getting something out, and I'm going to start going into checking the controls, because as you know, if the controls are all crapped out and dirty and they're causing intermittent behavior, and in other words causing the waveforms that you see there to drop out or get all staticky, you're going to see that on the scope. So a lot of you know this, but I'm explaining this too because, as I mentioned, I'm passing video footage on to the customers. If they want to sit through all this, they can. But at the very least, if I encounter a problem, I am going to want them to see that. So that said, on camera, I'm not going to go through every single step when I test the various inputs. I'm not going to, have the camera rolling through all that, because that would get very lengthy. But if I do discover a problem via a particular input, a particular mode, then I'll bring the camera back in, because I'm going to want to show the customer that anyways, of course. And also too, I have that second unit here, another receiver that I have to deal with. So I want to get through this as fast as possible, provided I don't run into any other hidden little gems of problems. Let's go ahead and get started. I'm going to zoom in on the screen there. So the left channel is the blue trace, okay, and of course the right channel is that yellow trace. So just keep that in mind. And let me get zoomed in, change the camera view for everybody, and we'll go from there. Okay, all you fine people, so here we are. We have signal on both channels via the auxiliary 1 input, 1 kilohertz tone. That's looking okay. So what I'm going to do obviously is just some down and dirty testing to see if these controls are causing any problems, are causing the signal to go intermittent or get jittery, staticky, and you'll see that on those waveforms if that happens. Obviously, if we lose signal on one or both channels, well then you'll see the bumps there, the waveforms, one of them or both of them drop out and go flatline like this. They'll just go flat. And you see what's happening right there? I just moved the selector switch, okay? I moved the selector switch from auxiliary 1 to auxiliary 2 and then back up. And you see how intermittent that selector switch is just from doing that. You see what's going on there? Boom, and then now it popped back in. So obviously that tells us that selector switch is dirty, okay? It's causing intermittent behavior. See, I'm kind of messing with it now again a little bit, see? So, yeah, it's dirty. It needs to be cleaned, no surprise. So anyways, stuff like that, that's what we're going to be getting into with just going through the controls, and that's why I want to do that, because I want to know where things stand. And I always suspect with this gear, especially when you open them up and they're really dirty inside, and all of this vintage gear that's multiple decades old, that's very common for these controls to be problematic to varying degrees. And sometimes if it's not dirt, sometimes there could be another issue going on with the controls. They could be just worn out, wear and tear. There can be, internal, an internal defect with the contacts, so forth and so on. But usually they're just really dirty and need to be cleaned out. The contacts can be badly tarnished or whatever. So anyways, without getting into all that though, problematic controls, very common thing. That's why in this case where the customer was saying, well, I think there's a bad channel or something like that, even though there could be something going on, and in this case it's not, because we have both channels. But if there was a dead channel, yeah, sometimes that could be because of a control, connection issue, so forth, so on, bad solder joint, faulty component, whatever. But that's what we need to suss out, and that's what I'm doing. First things first, just go into the controls, start moving them around. And you saw we had some intermittent behavior of the selector switch. So the same thing, I want to see if we have noise. And if there's noise, you'll see that too. You'll see some staticky looking artifact riding on the waveform, whichever one, or waveforms. If we have static, it's pretty obvious. Sometimes the controls just get jittery and bounce around. Anyways, starting with the volume control. Now we know the selector switch is dirty and it's a bit intermittent. So here's the volume control, and you see on the yellow waveform, you see that static. Every once in a while you see there's more static on the right there. Okay, I was able to see it. Hopefully you did too. Here's our balance control. And pardon me if I bump the volume control and decrease or increase the amplitude, because the balance control is on the same shaft and it's just a little thin ring that I'm turning, so my fingers might bump the volume control as well. But anyways, the balance control looks okay. So let's just get through this treble. Let's see. Yeah, treble controls looking good. Nothing alarming there. Mid-range. Yep, that's looking good. Looks pretty clean. Bass. Nothing to write home about there. Let's start pushing some buttons. Here's our high-low filters. Okay, it's looking all right. Our audio muting, minus 20 dB control there. Nothing alarming there. Our speaker select switch. I'm going to test the various terminals and all that, speaker terminals later. Right now I'm hooked up to A, so we're going to go from A to off. Okay. And just moving it from A to off, off to A, and so forth. It's not causing any jittery or funky behavior of the speaker select. Although again, all the controls are going to need to be clean. But let's go ahead and move on because I got this other receiver I want to perform the same testing with, see where I'm at so I can establish a baseline. And so here's our loudness, mono of course, everything's looking good. Our tape controls, tape 1, tape 2, yeah, nothing alarming there. And again, our selector switch, you know, we already know that that's intermittent, but let me go ahead and switch it on over to FM. I'm just going to go to FM. I'm not going to worry about AM right now because in this area, especially this time of day, there's nothing to lock in on. In fact, you know, I would need an external antenna, and then, you know, maybe late into the evening I might pick up something, but whatever. There was or maybe is a sports station, but I don't know if they're on all day. I don't think so. So there's FM, and we got some noise there. Let me see if I can tune something in. There's a country station. Let's see here. Yeah, I think there it is right there. Yeah. And that, I should be getting it better than that. In fact, I should be getting the stereo light, and I'm not. Or it might be flickering a little bit. It might be really dim. But yeah, I should be pulling in that station really strong with stereo separation. That stereo light should be coming in. Let me tune around and see if I get anything else. Yeah. I don't have an antenna hooked up, but I shouldn't have to for that particular station. So there's probably decreased sensitivity. This might need an alignment. As I go in and clean this thing out, and both of these receivers, I'm going to clean the tuning condensers too, because there's a lot of fuzz and debris, you know, all throughout these two receivers. So I really got to blow these out, vacuum them out. And the point I'm getting across is I'm going to clean the tuning condensers, re-lubricate the bearings of the tuning condensers and all that stuff, just freshen up everything. And but I may need an alignment on this unit, maybe both units, I don't know yet. But I should be getting that station a little bit better than that. Let me tune around just a little bit more, and then I want to move on. Let me see here. Okay, here's another station. I'm not really sure what it is. It might be another country station, because I know there's another one in this area here that, let me see, that's pretty strong as well. And this one I am getting a little bit of a, yeah, I am getting some stereo signal. The FM stereo light pulled in, and it flickers a little bit here and there. So the point is, I have reception. Okay, the tuner's not completely dead. It's not deaf. It's not gone. So that's a good thing. That's promising. So maybe just, and it looks like the dial tracking is off. So anyways, I'll probably have to do that. Adjust the dial tracking, align the FM, peak everything out, you know, sensitize everything, and go from there. But I'm going to worry about that a little bit later. I just want to get this other receiver in this position here on the right side of the bench, get it all hooked up, and see what there is to see. If I have signal on both channels. I know that on that other receiver, the customer was saying that there was no audio. Now I don't know if he was talking about the tuner or if he tried any other inputs. The reason I say that, because remember, I have that open fuse, that shorted diode and all that from that supply that feeds the tuner board, and or some of the circuitry on that tuner board. So, and I haven't looked at the schematic or anything, but I know that's the case. I know it feeds a tuner board somewhere. So anyways, I'll look into that a little bit more as well, but I just want to see what we have and see if there's signal on both channels. So let me go ahead and get to that. Okay, receiver number 2, safe power up. Let's give it a go. Small bulb on the left. Okay, we got our protection relay, good. So I'm going to monitor that for a little bit, and if everything does okay, just like the other one, then we'll get it all hooked up and go into the same testing and see what the controls are doing and all that stuff. So let me go ahead and get to that. Okay, and here we are with the other receiver, the one that was originally on the left side. And I feel like we've done this before. Anyways, so it passed with flying colors as far as the safe power up test. It idled for a while, nice and stable, not a single hiccup once again. We have signal on both channels, and this was a receiver that on the tag, the complaint is no audio. So I have audio at least via auxiliary 1 input. I'm going to check the other inputs. As suspected, because we lost that supply, that I think it's just off the top of my head, that 13.8 volts or 13.5 volts, whatever it is, when that fuse opened up, and of course, you know, we have that shorted diode. In other words, I have to check that circuit in a little bit more detail and go through it. I want to check that pass transistor. I want to just go through and really comb through that circuit. But I just want to go through this basic down and dirty testing first. So let me go ahead and zoom in on that scope, and we'll go through and see what the status of the controls is. One thing I will say, I noticed just before I even powered this up, when I was just feeling the controls, some of them feel really stiff. So these controls, I can tell, are in worse shape, at least the feel of them. So anyways, let me zoom in. Okay, and here we are looking at the waveform on this other unit, or waveforms, signal on both channels, in other words. And as you can see, we have it. So this receiver, the amp section, is putting out. And these waveforms actually look good, as a lot of you can see, those of you who know what we're looking at. So again, our left channel is the blue, our right channel is the yellow, obviously. And these waveforms are clean. So I'm not going to get into output testing and all that to see how many watts these things are putting out, if they're putting out the wattage they're supposed to be putting out. I'm not going to do that this go around. So let me go ahead and start with the volume pot. And again, we just want to see if there's any intermittent behavior that is brought about by these controls being absolutely filthy or otherwise defective in any way. And you can see this this volume control here actually looks better than the first one. The first one had some noise on the well, there's a little bit of noise as I climb up higher. There's a little bit of noise, so, but as to be expected. But the other one had noise right off the bat on the right channel more so. I'm gonna try to mess with the balance control, but the balance control on this one, yeah, it's a little bit stiff, and the volume moves with it because it's on the same shaft. You know, they're all stiff. So let me try to, with the other hand, hold the volume steady while I rotate the balance control. And yeah, there's a little bit of noise in there. You can kind of see that. There was a little bit of it, like right there. Yeah. Okay. But nothing bad. I mean, again, only to be improved by getting these controls all cleaned up. Treble, nothing scary there. Mid-range, looking good. Bass, looking good. Okay, I'm not going to camp out on these too long. Let's start pushing buttons. These high and low filters, high filter, not bad. And you'll hear me pushing them over and over again. Obviously, when a control is dirty, sometimes when you just exercise it a little bit, it will temporarily, key word, temporarily, resolve the problem. And, you know, so I like to see if it kind of clears it up a little bit. There's our audio muting switch, our minus 20 dB switch. Okay, nothing alarming there. Our speaker selector, so I'm just going to go from A to off. I'll check the other areas of it. I'll get some, you know, I'll rotate the speakers around and just make sure that all the terminals are working. I'm sure they're fine. And the selector switch is probably fine. This one doesn't look too noisy. There's B, there's C, there's A and B, so we'll get our signal back. So good. All right, so loudness control, looking all right. Little tiny bit of noise at first, but yeah, not too bad. Mono switch. Our tape monitors here, let's see. Okay, that's yeah, that one was getting a little bit intermittent. Let's see. Yeah. The tape monitor switches 1 and 2. This is 1, and it's 1 is a little bit funky. Yeah. 2 is not as bad, as you can see. Okay. And let's see our mode switch, our selector switch here, mode selector. Little bit, yeah, a little bit intermittent, not too bad. Yeah, a little bit of noise in the switch. It got a little bit intermittent, but I think the first one, the first selector switch was worse than this one. So there again, we have signal, and you know, we have signal on both channels. Also too, we didn't experience any hiccups during safe power up. Nothing was exhibiting problems within the power supply, so that's all looking good. Let me back out the camera a little bit. Okay, so there you have it. Everything's checking out okay so far as the preliminary evaluation is concerned. We have output via both channels, via both receivers, so that's a good thing. Based on the original complaints, the customers indicated that this unit here that's now on the right that was originally on the left, this thing was supposed to have no audio. I can see why maybe the customer may have brought that up, because if he's referring to the tuner, because of that issue that we're having with that, you know, that open fuse issue, the shorted diode, that, you know, that circuit that feeds the tuner board there, you know, that circuit is affecting the tuner. So that may have been what he was experiencing when he said no audio. As far as the other inputs are concerned, at least the auxiliary one, you know, we have, you know, that 1 kilohertz tone piped in. We're getting output there. I just need to check the other auxiliary number 2 input. I'm sure that's going to be fine. The phono input, I'm going to pipe in a phono level signal, see what's going on. And again, if there's a problem, I'll roll footage again and kind of go into troubleshooting that. But I don't want to put the cart before the horse and say there's going to be a problem. I don't know yet, but I'm just assuming that everything's going to be okay. And you know, but if there is a problem, I want the customer to see what that is, so I'll roll a little footage there. This unit here that was originally on the right, this is the one that the customer indicated had a channel issue, and I'm not seeing that. from the gate, this thing had output on both channels, as you know, we all saw. Before I backed the camera out, as you see it right now, before I did that, everything seems kind of instantaneous in a video, but before I changed views, I kept things running for a while and was kind of bouncing back and forth a little bit, and everything is status quo. Everything is the same. These two receivers have not deviated, fluctuated whatsoever at all as far as the output is concerned. The amplifier sections, driver sections are working, other than some irritable switches and potentiometers, and even that, not really all that bad, although I do recommend a very thorough servicing of these controls and you know, get these things cleaned out thoroughly, all that filth, debris, dust, fuzz, hair, all that junk out of there. That's what we should do right off the bat. If the audio proves to be favorable in terms of audio characteristics, it sounds good to my number one piece of test equipment, that is my ears, and it sounds good to the customer when the time comes, they can use these receivers, you know, as is. Some will say, well, yeah, but you should recap everything and all that. And yeah, you know, that wouldn't be a bad idea to do an electrolytic recap, but I don't have the time right now to do full bore, complete top to bottom recapping. However, if I do find other problems as I move along caused by some caps, electrolytics or otherwise, or you know, resistors that have drifted out of tolerance and all that, then yes, I'll bring that up. Yes, they will get squared away. And if there is going to be any recapping, if the customers want to do something to improve the reliability factor of these receivers, a good place to start as far as recapping is concerned, electrolytic recapping, is always going to be the power supplies and the amplifier sections, you know, the driver boards and all that. Get those electrolytics out of there, because electrically speaking, those are the areas that undergo the most wear and tear, and they have the most demand put on them, and so forth and so on. You know, the usual stuff I explained. And that I wouldn't mind doing. Even that I'll have to kind of work them, you know, in between some other stuff, do them in phases, you know, hit them here, hit them there, get them done, and then out the door. Because, you know, I am completely swamped. However, that's what I would recommend. Not necessarily going through and doing wholesale top to bottom recapping, unless, you know, I have the time to do that. You know, that's not always a bad idea, and it could certainly improve the sonic characteristics of the equipment if the equipment is starting to have some issues in those areas, as far as some caps, maybe even some transistors that are tiring out, that are starting to get electrically leaky, and have some other issues that are causing diminished performance as far as audio characteristics and as far as the audio performance is concerned. Otherwise, you don't always need to go there. Will something else fail? Who knows? You know, this is you know, 50-year-old equipment. I'll do what I can do to get these things functioning as they should overall. I now have a baseline, a place to start. Yeah, I'm just going to go ahead and end it here then, guys. You know, everything is looking pretty good with these otherwise, at least based on the you know, the primary complaints that came in on both of these. So anyways, as I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This is a poor man's shoe production.